Today we're going to look at writing and graphing equations, trig equations, that have shifts. So if we look at this first graph, if we want to write an equation based on it, the first thing we want to do is identify the midline. So we could take a look at this and see that the midline is right around 6. So I'm just going to draw a line here. So our midline is 6. If you can't tell what the midline is by just looking at it, what you can do is see the highest point, which is 12, see what the lowest point, which is 0, and just average it. So our midline here is 6, so we know at the very end of our equation we will have a plus 6. The next thing we want to look at is our amplitude. So the amplitude is the distance from the midline to the highest, or the distance from the midline to the lowest. So the distance here from 6 to 12 is 6, or from 6 to 0 is 6. So our amplitude is 6. Next thing would be determining if this is a sine or a cosine curve. Since the graph starts at the midline, that means that it is a sine curve. And finally, our last piece of information is figuring out the frequency. The frequency is how many cycles we see from 0 to 2 pi, or how many cycles occur in a 0 to 2 pi interval. So I could see that this graph goes from 0 to pi. Well, there's one cycle, there's one full cycle of sine from 0 to pi interval. So if there's one cycle from 0 to pi, well, then it would make sense that there has to be 2 cycles from a 0 to a 2 pi interval. So my frequency is 2. The last thing I just wanted to take a look at is if this is a positive or a negative sine graph. It's positive, so I can leave it as just 6 sine. Our next graph, first thing is to identify the midline. We could see that the midline is at 8. Again, if you're really not sure, you could always average the highest and the lowest point. So since I know the midline is 8, my equation has a plus 8 at the end. Okay. Next thing is determining whether it is sine or cosine. Well, since this doesn't start at the midline, that makes it a cosine graph. Now remember, a cosine graph would look like this. This one is a reflection, starts below first, so that means that it's a negative cosine graph. I'm going to put a negative there. Now let's figure out what our amplitude is. So the amplitude is distance from the midline to the lowest, or from the midline to the highest. So this is 3 to 8 is 5 units, 8 to 13 is 5 units. So the amplitude is 5. So we're looking at y equals -5 cosine. Last part is our frequency, how many cycles we see from a 0 to a 2 pi interval. This one's a little bit nicer because we can see this graph goes from 0 to 2 pi, which is nice. We don't have to extend it. So there's one cycle from 0 to pi, and then there's another cycle. So altogether there are 2 cycles. So since there are 2 cycles, we could say our frequency is 2. So our final equation is y equals -5 cosine 2x plus 8. And finally, our last example. We'll take a look and see what our midline would be. Looks like the midline is at 5 for this one. Next, we'll determine whether it is a sine or a cosine curve. This one looks like it is a sine curve because it starts at the midline. So we have y equals positive sine curve, and we said the midline, or the shift, vertical shift up, was 5. Now our amplitude. Distance from the midline to the highest, 5 to 15 is 10, or distance from the midline to the lowest, 5 to -5 is 10 units. We said this was a positive sine curve. And the last thing is our frequency. How many cycles in a 0 to 2 pi interval? Once again, this graph goes up to 2 pi. So we just need to count how many full cycles we see. That's one cycle. And then we only have a half of a cycle. So altogether, we have 1.5 cycles. So 1.5x. All right, rewrite that a little bit nicer. Y equals 10 sine of 1.5x plus 5. If you want, instead of 1.5, you could do 3 halves. Okay. So now let's take a look at graphing. We're asked to graph y equals 2 cosine half x plus 1 on the interval from 0 to 4 pi. So that interval 0 to 4 pi, that would be considered our domain. So we only want to graph 0 to 4 pi, no more, no less. Like always, we want to write down all of our important information. So that's the amplitude, frequency, period. We're going to add in our midline, and we also have our critical intervals. Okay. So our amplitude, that's right here. The amplitude is 2. Frequency, over here in front of the x. Frequency is a half. Period. Remember, we use our formula 2 pi divided by frequency. So in this case, 2 pi divided by a half, that's going to be 4 pi. So again, what the period means is that one full cycle is going to end at 4 pi. So just a very rough sketch. This last part here, that should be 4 pi. Okay. Next is our midline. So the midline is the last thing at the end, the plus 1. So our midline is the line y equals 1. Okay. Our critical intervals, that helps us figure out when we're plotting points. Critical intervals is always period divided by 4. So in this case, 4 pi is the period, divided by 4 is pi. What that means is we are graphing a point every pi interval up until our domain. Remember, our domain was 0 to 4 pi. So we're plotting a point at 0, we're plotting a point at 1 pi, we're plotting a point at 2 pi, we're plotting a point at 3 pi, and we're plotting a point at 4 pi. Noticing I'm only going up by intervals of pi. So 0 to 1 pi, add another pi, add another pi, and add one more. So we have basically our outline. Next, let's go to our graph now. So we can go ahead and make our axes. So we'll go down the middle. And since we're starting at 0, we could really make this left aligned. And over here. Next thing that I'm going to do is just figure out a good scale. Looks like we don't need to plot that many points. I don't know, I'm going to skip 3 boxes. Make that pi, skip 3 boxes. 2 pi. 3 pi. And 4 pi. You probably could have skipped 4 boxes and that would have been a little bit better. You would have seen more of the graph, but that's okay. So one thing we probably should have added to our important information was our range. So the amplitude was 2. That means that if there was no shift at all, we'd be going from -2 to 2. But there is a shift. The whole graph is being shifted up 1. So if I just add 1 on to each of these, our new range is going to be from -1 to 3. So that will help us with our y-axis. I know that the highest point I have to go up to is 3, so 1, 2, 3. I know the lowest number I have to go up to is -1. And it may be a good idea to draw in the midline. I'm just going to put that in with a dotted line here. So that's my midline. We could label it if we want. That's y equals 1. Okay. Last part is just following the pattern of cosine. Here's our midline. Think of this as your new x-axis. So cosine, we know cosine does not start at the midline. It starts above if it's positive, so here's the first point. And following the pattern, we're going to go midline, then we're going to go below, midline, above. The last thing is to graph it in, try to make it nice and curved, try your best, and then we'll label it y equals 2 cosine half x plus 1. Okay. Let's look at another. This one we want to graph y equals 3 sine of x plus pi. Okay. If we have, if we're adding something inside the parentheses here, that means that it's a phase shift, so left and right, which could be a little bit more challenging. So let's take a look. Again, let's get our important information, our amplitude, frequency, period, critical intervals, and I'm going to add range here. Our amplitude is 3. Our frequency will be right here, that's a 1. Period, 2 pi divided by frequency, or just 2 pi. Our critical intervals, that's period divided by 4. So 2 pi divided by 4 is pi over 2. Our range doesn't look like we have any vertical shift, so our range is going to be from -3 to 3. Okay. The critical intervals is pi over 2, so why don't we go ahead and make our x-axis. I'm just going to get rid of this. We know our critical intervals, pi over 2. We know our domain is 0 to 2 pi. So let's start at 0, and we're going to go up by pi over 2 intervals. So 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. I'm going to stop at 4 pi over 2 because 4 pi over 2 is really just 2 pi. And I know I could reduce these. This would be pi. This would be 2 pi. Now that we have our x-axis, we can go ahead and make our x and y axis on our graph. I don't know why I did that with dots. Let's change that. So make that solid. Okay. For this graph, our starting point has been shifted. We've been shifted to the left pi. What I'm going to do is, when I make my y-axis, I'm just going to I'm not going to completely left align it. So I'm going to do it more along this way. So it's not completely left aligned, it's not exactly in the middle, and you'll see why in a second. Let's put down our critical intervals here. So 0, I'm going to skip, I'll skip 3. This is pi over 2. This is pi. 3 pi over 2, and 2 pi. Okay. Our graph is being shifted to the left pi, so I'm going to backtrack a little bit. I'm going to backtrack. I'm going to make this negative pi over 2. I'm going to make this negative pi, because this is basically going to need to be our starting point. Now, we don't want to, at the end, we don't want to connect it, because that's not part of our domain. So you'll see what we're going to do at the end. Okay, this is our new starting point because we shifted to the left pi. So think of this as our new origin. This is a sine curve, so it will start at the midline, which happens to be 0. Then our next point is going to go up. Then our next point is going to go down. Then down to the minimum, back to the midline, up to the max, and back to the midline. My domain was very specific. It is only from 0 to 2 pi, no more, no less. That means that when I connect, I only want to connect from 0 to 2 pi, so I only want to graph this. That's it. Now if you have an eraser, you could erase these points. If you did it in pen, just put X's through because you don't want that to be part of your domain. Last thing, it's not part of this question, but a simpler way to write this equation without any shifts at all would be y equals, well, it's a sine curve, but it goes down first, so it's negative. The amplitude is still 3, and there would just be no shift at all. So it would really be a negative 3 sine of x graph. The last question we are going to look at is a little bit different. This one, they don't tell us the equation, but they give us enough information needed to graph it. So it says graph one cycle of cosine, so one cycle would just be this, with amplitude 3, period pi over 2, midline y equals negative 1, and passing through the point 0, 2. So we have all of our important information. The one thing we're really missing would be our critical intervals. So maybe let's just figure that out. So our critical intervals, that would be period divided by 4. They tell us the period is pi over 2. So pi over 2 divided by 4 would be pi over 8. Okay. They tell us that this function is passing through the point 0, 2. So I'm going to mark that down. They also tell us our midline. The midline is y equals negative 1. I'm going to draw that in as well. All right. Since our critical interval is pi over 8, we want to graph one full cycle. So one full cycle, that represents the period. So this last ending point should be pi over 2. So I'm going to go up intervals of pi over 8 until I reach pi over 2. So we'll start with 0, then 1 pi over 8, then 2 pi over 8, 3 pi over 8, and finally 4 pi over 8. And 4 pi over 8, that's really pi over 2. Okay. So I'm going to skip 2 boxes, I think. That's pi over 8. Skip 2 boxes. I'll reduce that to pi over 4. Skip 2 boxes. 3 pi over 8. Skip 2 boxes. And that's pi over 2. Alright, so I'm about ready to graph it. I have, the first point it has to go through is 0, 2. I'm going to also go, that's amplitude of 3, so that's 3 above the midline, 1, 2, 3. I'm going to go 3 below the midline, 1, 2, 3. And that's the point, negative 4. Okay. So here's my first point. Then I'm going to go to the midline. Don't forget, go to the midline. Don't go to the x-axis. And I'm going to go to the minimum, midline, and then to the maximum. Do this in a different color. And then we'll just connect. Okay. And that is graphing trig equations with shifts.